Hey class, welcome to our first class online. Isn't this exciting? So today's lecture is lecture number 1. You'll get another lecture, same format. So what I'm going to do is upload it to YouTube, send you a YouTube link for each one of these. At least at present, that's my plan. Hopefully nothing goes wrong with that. So you'll get this lecture for Tuesday. Thursday, we're going to do a SmackDown. And so there'll be a separate lecture that you'll get for that, either before Thursday or on Thursday. So Tuesday's lecture is the one that you've got now. Thursday, you'll get that. That's the SmackDown. I've sent you an article so that you can read that article through so you understand and can follow along and make the most out of our SmackDown together. So today what we're going to do is spend most of the time reviewing Chapter 7, Statistics. I know I gave you assignments last week to watch some videos, or rather, I guess the week before that. Last week, I guess, doesn't really exist, right? And I want to give you more than just reviewing those videos. So we're going to review Chapter 7 together for a little while today, and then we'll look briefly at what's in Chapter 8. Most of that is for you to read so that you can do or let me put it this way. It's for you to read so you can have better guidelines for how to create your research proposal. You're probably starting to really think about that because you've got about a month before the final draft is due and until April 14th. Okay, there's a little fruit fly, so if I go like this, I'm not responding to weird internal stimuli. It's a fruit fly. I need to get a little thing of vinegar to fix that. Okay, so here we are, Chapter 7. We're going to review this. I'm not going to spend time going through the entire chapter again. That chapter is in your book. You can read it. I don't want to read it to you. But I want to give you a little bit of an overview. And maybe if you're struggling with it, this will give you a little bit of a help. A little bit like giving you some shelves to put the material on instead of just throwing it all in the closet willy-nilly. Now you can organize it with some intellectual shelves, right? That's my thinking. Okay. So we're talking about descriptive statistics and inferential statistics. And so let's talk first about what are descriptive statistics. So what you're doing with descriptive statistics is you're basically, just like it says, you're describing what is my sample? What does my sample actually look like? This is a bunch of people. Okay, well, a bunch of people is not very helpful. If you said, I have a bunch of people in my study, you don't really know what that means, a bunch of people in my study. If we say 75% of the people in my study are female, then you have a little bit more of a sense of what that means. If you say 75% are female and their average age is 40 years old, then you have an even better understanding. So if you just kind of think about how when you imagine this, your mind kind of gets more and more specific about what this group looks like. I think that helps. And so the next thing to look at is variability. So if the average age is 40, okay, maybe they're all between 38 and 42, which means the average age might be 40, and there's not a lot of variability in that group. And so if you imagine in your mind's eye what that group might look like, it's going to look a lot different from a group where the average age is 40, but the range is much, much bigger. Like say the range is 10 to 80 or 10 to 90. Then you've got a different picture in your mind about what that group looks like. And so it's really helpful for you to have a sense of what the average is and what the standard deviation is. The standard deviation is that measure of variability. So standard deviation of 20 is way different look than a standard deviation of like 2. Okay. All right. So descriptive statistics will describe the people in the study. If you have 2 groups, then you want to describe both groups. And so people know, are the groups similar? Are they different? Were they similar at the beginning of the study and then still mostly similar at the end except for what your intervention did? Or are they similar to on one hand, but different in terms of whatever variable of interest you're measuring in a frequency study? So makes sense? I'm hoping that makes sense. I'm going to give you the opportunity on your quiz to specifically ask questions for things that you didn't understand. So when you take the quiz, I'll have a question in there that says, what do you need more help on? And I'll look through those, and then in my next lecture, I will hopefully take care of some of those questions, right? Okay, so descriptive statistics primarily include measures of central tendency and variability. So central tendency, you probably remember this. This is like the mean, the mode, and the median. The average is the mean, right? Then the mode is the most frequent number given. The median is sort of the middle of the distribution. The median as the middle is not skewed by extreme values like the mean or the average would be. And so a lot of times when people use the median, what happens is that there are a number of extreme values that will skew or kind of create an average or a mean that is different than the middle of the distribution. And so it's sort of deceptive. That mean is deceptive. And so median can be useful if your sample has some extreme values in it, right? So the thing to remember, descriptive statistics describe the group, and they're generally measures of central tendency. What does the average person look like? And measures of variability. How close together is the group, or is it pretty wide spread out on those variables? Okay, descriptive statistics. Next is inferential statistics. So you've got your descriptive statistics over here, then you've got inferential statistics. Inferential statistics are where you're trying to figure out if the stuff that you found out about your sample also can apply to the population as a whole. And so you're getting a sense of how likely it is that your findings are really unique to your sample, or if they're kind of on target for everyone else. So the p-value here is a value that is mathematical. So p is 0.05 or less. That's generally where we put the p-value. What p means is this. P is the chance that you got your result out of the blue. You got it either because that's really close to what the actual population is, or if your value is so different that it's unlikely that that's what the actual population is. In other words, 5% of the time you would get this value simply by chance. And so what you're saying is, did we get this value simply by chance? Or is this value actually legit different from the population value? Okay, so let's say we have two groups, and at the beginning their weight is the same, and then they're going to do this weight loss intervention. Let's say they take an herb, and they want to say, does the herb help you lose weight because it's managing your cravings for sugar or something like that? And so half the group doesn't take the herb, the other half does take the herb. And then at the end, they're measuring how much weight they lost and how much of a craving for sugar that they have. And so if at the beginning both groups are the same on all of their values, we use descriptive statistics to show that they're pretty much the same. At the end of the day, what you want to see is if the people in the group that took the herbs are significantly different than the people who didn't take the herbs. And when we say significant, what we're meaning is statistically significant, which is different from saying a lot or really, or the way we use significant in other language. When we say, wow, that is a very significant finding, what we mean by that is that's a big deal. And so with statistical significance, what you want to say is that mathematically it is different from what you would expect if the person was still a member of the original population. And so you're just saying there's a statistically significant difference. It's significantly different from the group. It's never really significant or way, way, way hard significant. It's not that. It's just, it's either statistically significant or not, one or the other. Okay, so the p-value being p equals 0.05 means there's a 5%, 0.05, a a 5% chance that you got this difference just by chance and not because it's a real difference. There's a 95% chance that the number you got is because there's a real difference. Does that make sense? Okay, I'm hoping it does. We'll go over a couple examples. And so what you're trying to do with inferential statistics is prove that the null hypothesis is false. So hopefully you read the chapter and you understand what the null is, but just in case you didn't, let me review. The null hypothesis is basically the hypothesis set that says there's no difference. There's no effect, there's no difference, there's nothing of interest here, nothing to see here, move along, right? So if you can remember, null is dull, reject the null hypothesis is your goal as a researcher. You're hoping that what you're doing is you're saying, like in our example before where we talked about some herb and weight loss, you're saying this really happened, it's not just the same population. You're saying there was an actual real difference. So you're rejecting the null hypothesis, okay? Now, if you reject the null hypothesis with your data, what you're saying is there's a 95% chance that your number represents a real difference. And there's only a 5% chance that your number is just out of the blue luck and it doesn't actually represent the truth of a difference. Like you got that number by chance, but there's no real difference there. So that's one of the errors that you might. Let's say that you got that number by chance and there's no real difference there. So we ran this study, we gave them all the herb, they come back, some of the group looks different, some of the group is not actually different, but they just happen to look different out of chance. And so what we're saying is the herb didn't do anything. It didn't do anything, but our group still looks like it did. That's a type 1 error. Type 1 means the truth is that herb didn't do anything. But the study said that there was a difference. Your numbers said there was a difference. And those numbers just were a random accident. Okay, so that's a type 1 error. When you're finding an effect, but the truth is that there is no effect. And so the reason we set P at 0.05 is because we want it to be that there's 95% chance that the random chance is not involved. Okay, let me say that again. The reason why we put P at 0.05 is we want it to be 95% chance that it's not random error. We only want a 5% chance of random error creating those potential differences. And so we have a 5% chance of making a mistake, 95% chance of not making a mistake. So if we say there's no effect there, and that's the real truth of the universe, which we don't have access to, but let's pretend we know there's no effect there, and our study says there is an effect, there's only 5% chance that your study would say that. So the odds are, the probability is that that your random chance, it's 5%, so it's unlikely that you'll have that happening. Okay, that's a type 1 error. There's actually no effect there, but your study said that there was an effect. And so your study ran into that 5% of random chance. Type 2 error is the other side, the other type of error. And that says there was an effect there, but your study just didn't see it. So either your study wasn't designed very well, or again, a random chance happened and you didn't happen to see the effect that was there. Maybe your measures weren't very good. Maybe there was a lot of error or sloppiness involved in your data. There are lots of reasons for a type 2 error, okay? We'll keep going over that. We're gonna go through some examples. So we're just gonna grab these from Reddit like we did with independent variables. So here I've listed these on the screen. But these are some recent studies in Reddit that we can just dismantle and look at null hypothesis, the alternative hypothesis, what a type 1 error would look like, and what a type 2 error would look like. We're going to go through a bunch of these a bunch of these examples, and I'm hoping that after this, you'll get this. You'll understand what is the null, the alternative hypothesis, type 1 error, and type 2 error. Okay. And just as an aside, I think maybe I'll say this again. I can't remember. And that is, the null hypothesis is something you reject, but you never accept it. So if you can kind of think, null is dull, right? I'm never going to accept anything dull into my life, right? So you never accept the null. The reason being that we figure we can reject the null because we're saying it's very, very unlikely that the null hypothesis is true if I keep finding the same effect. Let's say I find it in 5 different studies, and every single study I had a 95% chance of saying that this was not just random error that I found this, which means that it's a very, very small amount of error that a small amount of chance that you would be able to find that finding 5 studies in a row. Very, very, very unlikely. And so you can be pretty confident in rejecting the null hypothesis and accepting the alternative hypothesis, which is the hypothesis of your study. So back to our original example, if the alternative hypothesis is, yes, this herb actually helps people curb their carb cravings such that they end up losing weight. That's the alternative hypothesis. And so we reject the null. We say, look, we found that this group had a statistically significant difference. And the chances of getting that result by random chance is less than 5%, less than 0.05. So we set P equals 0.05. So anything that's 0.05 or less means that our sample is different from the other sample, that difference. Okay, so here's the first study. Smell may shape how our brains process memories. So if you know much about how brains process memory, that's very, very complex. And the idea that smell has a role in shaping how the brain processes memories, well, that's pretty interesting. I kind of think about it in terms of your limbic system alerting you to danger. And so if you have a memory that is a traumatic memory and there were smells involved, we know those smells they go straight to your limbic system for processing. And so they could be involved in how traumatic memories are processed. Anyway, a little psychological interest for you there. But here, what we can do is just look at the null hypothesis, alternative hypothesis, type 1 error, and type 2 error. And so in this case, if the study's saying smell may shape how our brains process memories, that is their alternative hypothesis. They're sort of saying it in that phrase. And so the null hypothesis, remember that's the hypothesis of nothing. Null is dull. Null hypothesis is this: smell has no effect on memory processing. And then the alternative hypothesis, or the study hypothesis, or the scientific hypothesis, there are lots of ways to think about that, but we call it the alternative hypothesis. And that is smell does affect memory processing. And so we do the study and we look at the chances of getting our results just by random chance. What is the probability we'll get our results by chance? If that probability that we get those results simply by chance is less than 5%, then what we do is we say we accept the alternative hypothesis and we reject the null. Okay? So what we're doing is rejecting the null. There are 2 errors that might happen. And so what we have to do when we think about errors is imagine that the truth is out there, right? Imagine the truth is out there and that we kind of know what the truth is, which of course we don't. So in terms of scientific thinking, we don't ever know what the truth is. All we do is we get lots and lots of evidence and we build that evidence up. And so a type 1 error would be that the truth that's out there is that the smell actually has no effect. But what we found in our study was that it does have an effect, okay? And so we have a type 1 error if it's true that the smell has no effect. We won't know that we have a type 1 error. We won't know. All we'll know is that in our study, it showed smell had an effect. So until we do a whole bunch of studies we are not 100% confident that we haven't made a type 1 error. There's still a 5% chance or 5% probability that what we got was just by chance. So you do several studies. That's why replication is important. You do several studies and you realize, oh, okay, so the weight of the evidence is on one side or the other. Or you could say, well, that one study, that was a fluke. And so when we say that study was a fluke, what we're really saying is there was a type 1 error. The fluke is that we found smell had an effect when the truth is it actually didn't have an effect. All of the other studies showed that it didn't have an effect except for that one. So that one must be type 1 error, right? But the problem, again, with science is that it never will find truth. You never prove anything, ever. You just accumulate evidence. So if you want to prove things, I don't know what to tell you, but maybe science is not your thing, because proof scientifically is about gathering evidence that leans towards something. You always have in your mind, we've never 100% proven something. You can say, yeah, we know, or we're extremely confident that this is true. That's how scientists talk. That's why they say things like, this may be, it's probable, it's very likely. We don't use the C word very frequently, causality. That's like really crazy for us to use. Okay, that's type 1 error. Type 2 error. Type 2 error is that the truth is that smell does have an effect, but our study didn't find it. Okay, so this is where you start looking at what's wrong with the study, so it didn't find the truth. And this is where you look at internal validity, maybe external validity, maybe there was bias, maybe there was measurement error, maybe your sample was not drawn correctly, all kinds of reasons why type 2 error might happen. And so as you're designing studies, what you're trying to do is reduce the likelihood of type 2 error by making your study very airtight. You want to look at internal validity. You want to look at bias. You want to look at your measurements. You want to make sure that you have all of your ducks in a row so that you reduce the likelihood of making a type 2 error. Okay, so type 2 error would be, the truth is there was an effect, you just weren't able to find it in your study, right? Okay, next example. People with behavioral addictions have losses in gray matter. So gray matter is a kind of brain cell. You have white matter, you have gray matter. People with behavioral addictions have losses in gray matter volume comparable to people with substance abuse. And so we know people with substance abuse lose gray matter. What they're saying here is that people with addictions that are not substance but behavioral addictions, they also lose gray matter. And so give it a thought for a second. What would the null hypothesis be? What's the alternative or the scientific hypothesis? And to give you a hint, that the sentence there, people with behavioral addictions, that sentence is the alternative hypothesis. That's what the scientific hypothesis is. People with behavioral addictions have losses in gray matter. Those losses are comparable to people with substance abuse. So the null hypothesis, think about it. The null hypothesis would be people with behavioral addictions don't have losses in gray matter that are comparable to people with substance abuse. That's the null hypothesis. That there's not a difference from what you would expect. Okay, type 1 error would be that the truth is that there is no difference between, okay, this is confusing because of the way this is worded. So the type 1 error would be that people with behavioral addictions have losses in gray matter that are not comparable to people with study abuse. In other words, when we're saying there's no difference, what we're saying is they're not the same as substance abuse. They're just, losses in gray matter that aren't comparable. So a type 1 error would be that the truth was they weren't comparable, but we found that they were comparable. So that's a type 1. Type 2 would be that they were comparable, but we found that they weren't. Okay, we'll go on. We'll do some more in case that one was confusing. All right, I'm going to see if I can move my self over here. Hi, self. There I am. Okay, so the next one is this. Insufficient sleep in childhood can increase the risk of mental health issues. Insufficient, so not enough sleep when you're a child can increase your risk of mental health issues. The answer to this, of course, is yes, it can. That's what the study found. But what we're looking at is what's the null hypothesis and what's the alternative hypothesis. So the null hypothesis, what would it be? Give it a thought. So the null hypothesis would be poor sleep in childhood doesn't make a difference, right? Null is dull. Poor sleep in childhood doesn't make a difference for mental health issues. And the alternative hypothesis is what's stated. Poor sleep in childhood does make a difference. It ups your risk of mental health issues. Okay, type 1 error, if you remember, type 1 errors are that you found something that isn't real. You found it, but it's not real. Type 2 is you didn't find it and it was real. So type 1 would be they found that poor sleep ups the risk of mental health issues, but the truth is that that's not really reality. That the truth is that poor sleep doesn't make a difference. But this study found that it did. So that's a type 1 error. Type 2 error would be that we didn't find that it made a difference when in fact it did. So the truth is that poor sleep really does up your risk of mental health issues, but that's not what we found in our study. In our study, we found that it didn't make any difference at all. So that's the difference between type 1, type 2 error, okay? Hopefully that's making a little more sense. Let's move on. Next example. The next example is skipping breakfast is linked to a greater risk of depression. So the null hypothesis would be skipping breakfast doesn't matter. That's the null hypothesis. Type 1 error, think about it. Type 1 error is you found an effect that's not real, right? So the type 1 error would be that the truth is skipping breakfast doesn't matter. But your study found that it did matter. Your study's wrong. It found that the probability of what it did was found it by chance, and it was just random chance. Okay, that's type 1 error. Type 2 error would be the truth is skipping breakfast is linked to greater risk of depression, but then your study didn't find that. So you have a type 2 error if your study didn't find the truth. Okay. We'll do a few more. Daily supplementation of vitamin D is superior to less frequent supplementation. So what the specific thing that it's superior for is immune effects. It's not superior for bone health, but it is superior for immune effects. And so the null hypothesis would be daily supplementation of vitamin D doesn't make a difference. It's not superior. It's the same as less frequent. That's the null hypothesis. Type 1 error would mean that the truth is that supplementation is superior, but what your study showed was that it wasn't. That's a type 1 error. Type 2 error would be the truth is daily supplementation is superior, but what your study found was that it didn't matter, and that's not accurate. So your study wasn't good enough to find the truth, or your study found that it wasn't different based on just random chance. Okay. Look at the next two, see if those make sense to you. I'm going to give you a second to just kind of look at them and try it out, and then we'll see if you get it. Okay, air pollution. Null hypothesis. The null hypothesis is that air pollution doesn't make a difference, right? Let's just look at type 2 error. Type 2 error would be that the truth is air pollution really shortens lives, but you didn't find that in your study. Make sense? Type 1 error would be that you found that air pollution shortens lives, but the truth is that it doesn't. Okay, so type 1 is always whatever the truth is, you didn't find it. Sorry, that's type 2. Type 2 is that whatever the truth is, you didn't find it. And type 1 is that what you found was random error. Okay. We're going to move on. Let me know if you want more work on this next time, because if you do and you're still confused, we'll definitely fix it. All right. So we talked about never accepting the null hypothesis because we don't know the truth, and how we only collect evidence. That's what we do, is we just collect evidence. And so as scientists, the assumption you make is that you don't know the truth. All you do is collect evidence, and then you end up with what they call the weight of the evidence. So if you have a really, really great study, people might say that's such a good study, it has to be true, but you always need to replicate. Always need to replicate to make sure that the next study still says the same thing. If you have multiple studies that say the same thing, you have much more weight of the evidence instead of just one study. You never accept the null because you don't know the truth, right? You might have had a type 2 error. The null might be likely, but you don't ever accept it because you never really know for sure it's true, okay? You can look at your text again, page 166, and kind of review that. Okay, next thing we're going to do is look, okay, I'm sorry, I'm going to have to move this around again. I didn't realize I was so in the way. Okay, if you want to understand the frequency of your variables, what you're doing is a frequency study. Okay, so look at your research proposals and kind of imagine, what kind of a study am I doing? Is it a study of frequency? Hopefully you talked to Corey about this. A study of frequency, or study of association, or of causality, okay? So in any of those studies, but particularly with the frequency, where this is what you rely on, you want to look at descriptive statistics. You want to describe your sample. And so here's a frequency study. How many Southern Virginia University 18-year-olds went on a date last month? That's a study of frequency. And so the descriptive statistics would be the number of 18-year-olds, how many men and women, what majors were they, what sports did they play, all the sort of thing. Those are descriptive. But if you want to understand whether there's an association or a causal relationship, then we use inferential statistics. Okay, so if you're looking at an association, you want to see if one of your variables is associated with the other and they're both continuous variables, then what you do is correlation. We're just going to do a couple simple ones here. I'm not going to go through all the statistics that there are because that's not what this class is. So I'm just going to give you some simple ideas. So if you want to look at association, like is there a connection between how much ice cream you eat and how old you are? Then you want to do a correlation. Both age and amount of ice cream you eat are continuous variables, right? So a correlation is a statistic that you run, and the result is an R value, okay? So if I say I'm going to run this correlation, then I do some math, or I ask my computer to do some math for me, and the end of the math says R equals. So you have an R value, okay? If when you're correlating, age goes up and ice cream goes up, then you have a positive correlation. If age is lower and ice cream consumption is higher, then you have an inverse correlation. One goes up, one goes down. If they both go down at the same time, that's also a positive correlation. It's positive because they're both going in the same direction. Okay, it's not positive because they both go up. It's positive because they both go the same direction. So if R is 1.0, if your R value equals 1.0, that means it's perfect. It's a perfect positive correlation. Every single time one thing goes up, it goes down the same amount across the board always. That's perfect. So it's either 1.0 or negative 1.0 for positive or an inverse or negative. If it's closer to 0, like let's say your R value is 0.05. That's pretty close to 0. Or even 0.12. That's pretty close to 0. Then you really have no correlation. There's no real relationship between those variables. And I'll tell you that in a second. The statistic here depends on whether you get an R value if you have continuous numbers. We talked about both variables are continuous, like age and level or amount of ice cream that you eat. If your data are not both continuous, if there's some of them are categorical, like let's say you are looking at gender and major, do people with theater majors or math majors, which what's the higher association with love of pistachio or strawberry ice cream? Okay, and so you've got either pistachio or strawberry, and you have theater major, and you have, shoot, I don't remember what I said, call it math major, maybe that's what I said. Okay, then you do a chi-square to see if there's any sort of pattern in those. You can't use a Pearson or a correlation. You can't use an R value because it's not continuous data. So you use a chi-square to figure out, is there a relationship? The idea here, though, is that you're still figuring out an association, a relationship between the two. If you want to look at differences between groups, then you're not doing a correlation. You're looking at differences between groups. So if we go back to that study we talked about at the very beginning, which was you take an herb and it helps you with carb cravings, and so you're not wanting sugar. Okay, so then you're looking at a group difference. And so the group would be, were you in the group that took the herb or a group that took the placebo? Those are two different groups. And then the continuous outcome measure would be amount of carb cravings. So then you want to see, is there a difference between those two groups after they took the herb? Then you're using a t-test, okay? So you've got one continuous measure, which is amount of carb cravings. You have two different groups. They took the herb, they took a placebo. And then you want to see, are the two groups different at the end of the study? So you use a t-test to figure that out. So the t-test looks at the average or the mean of one group versus the average or mean of the other group. It factors in the variability because that's going to make a difference in terms of comparing the means. There's a lot of variability, then the means have to be farther apart to be statistically significantly different. Okay, if they're actually different, then you get a t-value that you can see is statistically significant. You can, look it up on a table and it will tell you where the corresponding p-value is, or these days we don't do that. We just put it in the computer and it tells us. Okay, so it's all or nothing. It's either significant or not significant. It's not very significant. It's just statistically significant or not statistically significant. So it doesn't matter what value you get, it's still either significant or not significant. Okay, so get out your lab book and let's take a look at exercise 1. And you can pause here for a second if you need time to get your lab book. Okay, so lab exercise 1, here's what you're going to be doing. You're going to enter data into a graph. So in the lab exercise, it'll give you two different numbers, a number, a comma, a number. And so what you do is you plot that on the graph. After you're finished plotting that, take a look at what the graph looks like and then guess what kind of a correlation do you think it is. Basically, is it a positive correlation or a negative correlation or no correlation? So if you look at these graphs here on the slide on the right, what you see is what it looks like when you have a positive correlation, a negative, or no correlation. Okay, so positive, you'll see those pairs kind of going up to the right in an association. If it's negative, you see them going down. So as one is low, the other is higher, and you'll see them go down. If there's no correlation, they're just kind of all over the place. So that's basically what it looks like. So what I want you to do is plot those points on that graph, eyeball it. Eyeball it. You don't have to come up with a number. I just want you to come up with, do you think it's positive or negative or no relationship? And then answer that on the quiz that you'll have for this week. Okay, so here's another picture without the lines in it. So this is just the dots on the graph. They had fit a line to them on the other ones. There's no line on these, but you can see it looks pretty much the same. Positive, negative, and no relationship. All right, so go ahead and complete Lab 31. You can pause now, or you can do it later when you're doing the other labs. And take a look at your results. Whoops, sorry. And like I said, characterize the relationship, write it down. Okay, then what we're gonna do, I'm gonna move myself again. Okay, then what we're gonna do, whoops, is look at lab exercise 32. 32 is where we're gonna practice more of identifying the null and the alternative hypothesis, like we did just a few minutes ago. And depending on study results, what you're gonna do in lab 32 is choose to either reject the null or accept the alternative hypothesis. And just as a reminder, we never accept a null. And so what I want you to do is complete lab exercises 32, 33, and 34 as part of your activities and quiz for this week. Okay, so next we're gonna look at chapter 8 really briefly. Chapter 8 is about reporting research. This is just a really super valuable chapter for you to have, because what it does is it explains all of the things that you need to know for your research proposal, like I'd said earlier. It's the guidelines that you want. So I would encourage reading this chapter. Like, well, of course I want you to read all of them carefully. But in terms of applying this to your research proposal, chapter 8 is for you. It's basically all the guidelines. And so just a reminder, your draft is due April 14th. If you turn your draft in earlier, then I can give you feedback earlier and you can have more time to work on it before the final deadline. So you know, it has to be in by April 14th, but I strongly encourage you to get it in as soon as you can so you have plenty of time. The final deadline is April 25th. So what I want you to do in particular with chapter 8 is check out on page 184, there's a sample APA style report. It goes through the whole thing and it shows you exactly what it looks like on page 184. Super valuable for you. Basically, do yours just like this, only with modifications because it's a research proposal and not a report. And so modifications are: 1, leave out the abstract. You don't need to do that. You can leave out the results. I'm not going to have you go through and do a statistical plan because this is a research methods class, not, and some of you haven't had statistics and some of you had it. So I think it just makes more sense to leave that out. When you do the discussion, what you're going to be doing is writing out threats to internal validity and how you manage those threats. We're going to go through some of those next week. So don't worry that you feel like you don't know enough yet. We're going to go through those next week. And we'll go through a little bit in the smackdowns that we do also. What are the threats to internal validity? In other words, when people say your study wasn't good enough, how are you going to talk about how they're wrong? How are you going to say, no, actually, I designed it to take care of that problem by doing this, right? Okay, so your final proposal is going to look like the one that's pictured on 184, except without the abstract and the results. Be sure that you put your citations in text in APA style. So that means you have the name and the year, right, in the parentheses, and you have a space between your word and the parentheses, right? Okay, make sure you include those because that's part of your grade. All right, that's the end for today. You'll get your next lecture, your link to it, either on or before Thursday, this Thursday, March 26th. What we'll do is walk through another smackdown. I'll send you the link to that on your email. And I'll look forward to seeing you then. Thanks so much. Thanks so much. Yeah.